Hey, this is Mr. A, and in this video, we are going to answer one of the two most confusing questions when filling out a nav log, and that is, what is the distance to the top of climb? That if we're going to find out the distance, then it's speed times time. We need to know what the time to climb is and our ground speed. Ground speed is going to depend on the wind effect, which way the winds are blowing, whether we've got a headwind or a tailwind, and how strong those winds are. That's a lot of information you are going to have to gather, compute, and organize. Here's what you're going to need to get started. You're going to need your true course, which you've determined with your plotter and your sectional. You're going to need your weather briefing. You're going to need your performance charts that are found in the pilot's operating handbook. In particular, we'll be looking at the time, fuel, and distance to climb. You're going to need a flight computer. You're going to need a nav log to organize this information. And you're going to need a lot of sharp pencils and some scrap paper. In this example, we're going to be taking old 90212 X-ray from Oconee County, that's KCEU, to Donaldson Field, KGYH, to visit our friends at the Air National Guard. Now, in flight planning, one of the first steps you would have done was to complete your weight and balance just to see if you can get off the ground in the given amount of runway. And you would have also got your weather briefing. This is a brief briefing, just the information that we need to fill out our nav log and determine our top of climb. We're going to need to know atmospheric conditions at our departure airport, and here we've got the current observations with the METAR, and forecast weather at our arrival location, Donaldson Field. The winds and temperatures, barometric pressure are going to be important for our calculations. Also, the winds and temperature aloft. So please take your time to fill out this information if you have not already, because we're going to be having to reference it. I want to take a moment here to give a shout out to our friends at Aviation Supplies and Academics, ASA. I'm using these flight planners from ASA because they are the most comprehensive and well organized planners that I've used. Now, I don't work for ASA, but maybe they'll give me a nice ball cap for giving them some free advertising. To begin this process, let's start with your flight planner here. And remember, what we're trying to find out here is the distance to the top of climb. And in order to find that, we are going to need to know how long it takes to climb to the top and what our ground speed is. If we know the speed and the time, we can find the distance. Begin with entering your true course, which you found with your plotter and your sectional, and your cruising altitude, which is the way you determine that is like a whole nother video. But we've decided that our cruising altitude is going to be 3,500. Draw you a little picture of what that looks like here. We're starting at KCEU and their field elevation of 891, and we're climbing up to our cruising altitude of 3,500. They only give you one box to put altitude in here. So what do we put in here? Well, it's the average altitude of 891 and 3,500. So I made a little sheet here where I can do that calculation. So our average climb altitude, you just add these two numbers up and you divide by 2. Get a little calculator and you can get that number for yourself. 2,195.5 is the average of 3,500 and 891. So let's put that in this box right here. Again, this is the average, 2,195, 2,195. Our friends at ASA also sell a handy dandy flight computer That's going to come in real handy. This is the physical flight computer, but they also have an app for your phone. Now then, for these next three boxes, wind direction, velocity, and temperature, same thing. We're going to have to take the averages because we know that our winds and temperatures aloft are different than the winds and temperatures on the ground where we took off. So continuing this little table that we made here for calculating averages, wind direction at 3,500 is 271. When we took off, it was 140. So you'd add those two numbers up and divide by 2. That's 205. Wind speed is 21 knots at cruise, 9 knots when we departed. That's a total of 30 divided by 2. So velocity is 15. And then our temperatures was a little cooler at altitude, 14 degrees where we took off. 13 is the temperature. I want to take a second to give a tip of my hat to Scott Coons, CFI, for helping me understand this next part. This next box is asking us for our true airspeed during the climb. For that, we're going to need our time, fuel, and distance to climb performance chart that's found in your pilot's operating handbook. But here's the head scratcher about this chart. A couple of things. Number one, our airspeed is given an indicated airspeed, and we need to look that up by our pressure altitude. So there's going to have to be some conversions going on. But I think it's safe to say that when we're operating here above sea level and below 4,000 feet, our indicated airspeed is going to be 73. We just need to convert that into true airspeed. So let's do that on e6bx.com. All right, here we enter our average altitude during the climb, 2195. Our barometer, which was 30.16. Our outside air temperature is 13. And our indicated airspeed off the chart, bang. And there we get true airspeed, 75. Now then, to get our wind correction angle, we're going to have to go back to e6bx.com. Here, wind correction angle is not one of these calculations that we see here in the drop-down box, like where we found true airspeed. It's actually a separate tab over here. Here we fill in the information requested, beginning with our true course, 085. Our true airspeed, which we just found, which was 75. Our average wind direction, which is 205. Average wind speed, which is 15. And here we get a wind correction angle of 10, a heading of 95, and a ground speed of 81. Record that information in your nav log. We are almost there. We just need to figure out how much time it's going to take us to climb. Going back to our time, fuel, and distance to climb performance chart, we can see the time to climb to an altitude is given in minutes. And the way that this chart works is that if we started at sea level and we climbed to 5,000 feet, then it'll take us 8 minutes. But we're not starting at sea level. You remember, we're starting at Clemson, which has a field elevation of 891. Now, field elevation isn't listed here in altitude. It's pressure altitude. So we're going to have to convert. So go back to your drawing here and just real quick, use your calculator for a field elevation of 891 and a barometric pressure of 30.16. Pressure altitude is 671. And I'm going to write that in parenthetically here. And then our cruise altitude, if we enter that, with our barometric pressure of 30.16. Then we get 3280 for pressure altitude. Now, note that these are both less. Pressure altitude is less than our indicated altitude. So we round up. So 671 would round up to 1,000, and 3,280 would round up to 4,000. If our barometric pressure was a little bit different, then we'd be rounding up to a different number, but we're basically looking at these two rows on the chart. If we were going from sea level and climbing up to 4,000 feet, it'd take 6 minutes. But we didn't start at sea level, we started at 1,000 feet, so we have to subtract that 1 minute. So time to climb, according to this chart, is 5 minutes. Now, a couple things. You need to be mindful of these footnotes down at the bottom. In particular, this one, increase time, fuel, and distance by 10% for each 10 degrees above the standard temperature. As you might recall, that we are 3 degrees above the standard temperature when we're at our cruising altitude. So we're going to have to multiply this by some small amount. In this next scene, I'm going to do some quick math just to make sure that I compensate for our non-standard temperature. If you got a better way to do the math, let me know in the comments below. Okay, so our time to climb, if we were at standard temperature, would be 5 minutes. But we're not at standard temperature, so we need to add some amount. We need to add 10% for every 10 degrees that we are above standard temperature. But we're only 3 degrees above standard temperature. So let's do the math. On your calculator, we can enter that second term. 5 times 0.1 times 3 divided by 10. 0.15 is the second term. So 5 minutes plus 0.15 minutes. I don't know if that's enough to worry about. 5.15 minutes. We're getting really close. Now, you can enter that 5 minutes right here for estimated time en route, but to calculate distance, you're going to have to convert it to hours because our speed is in knots. So 5.15 minutes, you're going to convert that to hours. In 1 hour, there are 60 minutes. So minutes are going to cancel and leave us with hours. So 5.15 divided by 60 is 0.086 hours. All right. So then our speed is 81 knots. So distance, drum roll please, is equal to 81 knots. That's nautical miles per hour times our time of 0.086 hours. You'll see that our hours cancel and it's going to leave us with nautical miles. And so this times 81 equals 6.95. Can we round that up to 7 nautical miles? So we can put that right here for this first leg. And then before we're finished here, there's just a couple more things that we need to talk about on this time, fuel, and distance to climb chart. But first of all, you might wonder, well, why didn't you just read the distance off of this chart and put that into your nav log? Well, because of point number 4 here. Distances are shown based on zero wind. We did not have a zero wind situation. In fact, we had 15 knots blowing out of the southwest, and it was a tailwind because we were headed east. right? So we're going to cover more distance than what would be indicated on this chart for zero wind. As a matter of fact, if you look here, it says 8 minus 2 is 6 miles, and what we calculated was 7 miles. So the wind did blow us a little further down. The other thing that we need to talk about is point number 1 here on the notes. Add 1.4 gallons of fuel for engine start, taxi, and takeoff allowance, because this chart does give us the fuel used during the climb. So time and fuel are independent of what the wind conditions are. So we can pull our fuel used right off of this chart right here. So again, using the method that we did before, we're not climbing from sea level. We're climbing up to this rounded up 4,000 feet. 1.5 gallons minus 0.4 gallons. It's 1.1 gallons that we're going to use during the climb. But this note 1 here says add 1.4 gallons to that to your ground operations. That's, taxiing, waiting to take off, and all that kind of stuff. So that's 2.5 gallons that we're going to use for start, taxi, take off, and climb. And I want you to put that right here on fuel used. This video needs to be about over because I'm almost out of hats. But let's finish this first row of the navlog just for thoroughness and completeness. The variance in this neck of the woods is 7 west, so that's a positive 7. And remember, you get that information off of your sectional by finding the closest isogonic line. And so we can enter that in our little computer here, but these numbers are pretty simple and the math's not too bad. But we're going to enter our true heading of 95, our variance of 7. That gives us a magnetic heading of 102. You're just adding those two numbers, right? And then plus or minus deviation, which is the little deviate gremlins in our cockpit that make our compass not say the right thing. We're basically heading east here, right? And so if we want to fly east, then we steer 92. So the deviation is going to be a positive 2. So our compass heading, then let's see, enter that as a positive 2. Then our compass heading is at 104 degrees. Okay, so we got that, we got that, we got that. And as far as I'm concerned, that completes this row right here. Oh, sorry, didn't mean to scare you. I told you I was out of hats. Listen, you can finish those middle rows by yourself, or I'll make another video to help you. But definitely tune in for the video on the second most confusing question on a flight planner is, what is the distance to the top of descent? I'll see you there.